Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find the volume of a solid generated by revolving the region bounded by four equations here, as you see, about the x-axis. Okay, so I just wanted to pick this example as a good exercise because we have a trigonometric function involved. In the region, so it's cosine 2x, and we also have y equals 0, x equals 0. These are x and y axes, and x equals pi over 4. That's the vertical line. So I just wanted to have this example just for you to practice with the integration of cosine related integrand. Okay, so let me just quickly show you what the region looks like. So the region looks like this. You have the blue curve, which is cosine 2x, x-axis, y-axis, and the axis of revolution is x-axis, and also we have the part see, like the very right end of the region is bounded by x equals pi over 4, so that vertical line is x equals pi over 4. Okay, so I'm going to use the disk method for this purpose, and you're going to find the details within the video. All right, let's get started. All right, let's take care of this question. So we have the region bounded by four graphs. One is a trig function cosine 2x, y equals 0, which is in fact x-axis, x equals 0 is y-axis, and the vertical line x equals pi over 4. So why don't you go ahead and graph cosine 2x in between 0 and pi over 4, so x min 0, x max pi over 4, and see what the region looks like. And I'm going to show you right away what I have, and you can pause the video anytime to get your visual in your side. This is exactly what I got, and this is pi over 4, by the way, this point and the vertical line. And we're going to revolve this region about the line x-axis. Here we go. I'm going to revolve this region about x-axis. Okay. Well, this is probably what you're going to get. So let me just graph that. Okay. All right, so this is a pretty much straightforward three-dimensional object. It's easy to sort of like visualize in our minds. So I'm not going to show you the actual 3D graph. So what we're going to do today is we're going to use the disk method to find the volume of that object. So for that reason, I'm going to use a disk vertical to the axis of revolution. So it's going to be looking like this, just a representative disk. Okay. Let's say like this comes with thickness dx, and let's say this is x units far from the origin or the y-axis. All right, so all I need is the radius of the disk for me to write the volume of this disk. Okay, so let's just call it R. Okay? In fact, R is what? In fact, the volume is pi times R squared times dx, the thickness. Okay, the surface area times the thickness is the volume of the disk. Okay, and so R is the top part of the slice, right? So that depends on the curve because the top part of the slices, whatever slice you pick, in fact, another slice you pick if you want to, the top part is always touching the blue curve, right? So the bottom part is always on the x-axis. There's no problem with that. So I'm going to use the curve to write down R. R is going to be equal to cosine 2x. So in other words, this volume is going to be cosine 2x quantity squared dx. And x's are ranging in between 0 and pi over 4. Now I can go ahead and write down the volume formula by using the disk method. Pi 0 to pi over 4 cosine squared 2x dx. Okay. All right, let's use the power reducing formula because this is cosine squared. There's no direct formula in the basic integration formula card to integrate this. We have to use power reducing formula, which takes it all the way to cosine 4x plus 1 divided by 2 dx. Okay? And in fact, I can just pull out this half part here. So cosine 4x plus 1 pi over 2. How about that? This looks better. Let's integrate it. Pi over 2, 1/4 sine 4x plus x from 0 to pi over 4. And if you're having a hard time to integrate cosine 4x, you can go ahead and have a scratch paper and look at the integral cosine 4x dx for u equals 4x, okay? So that's a good u substitution practice for you, okay? Just do it by yourself. And here, this integral is going to be pi over 2, 1/4 sine pi plus pi over 4 minus 1/4 sine 0 plus 0. Okay? We're using the fundamental theorem of calculus. And sine 0 is 0, 0 is already 0. You have sine pi exactly equal to 0. Okay? So we're down to pi over 2 times pi over 4. That's pi squared over 8. Okay? And that's the volume of the three-dimensional object obtained by revolving this region around x-axis. Right? We use the disk method to get to the conclusion here. All right, this was a relatively shorter video for this section, so I'm going to end it right here. Thanks for watching, and I'll see you in another video. Bye.